Hello students, welcome to EduCell. This video is dedicated to space complexity. Here we will discuss how to find space complexity and why it is needed, that we'll discuss. As per the definition, the space complexity of an algorithm is that we discussed in the earlier videos. The complexity is needed to complete a task. If you add space, it could be said as space needed to complete a task is space complexity. In case of space, if you want to add time as complexity, then time needed to complete a task is time complexity. Task is could be like you are providing a solution to a particular problem. That is what is complexity. Next is now how to find the space complexity. Space complexity, if you are going to find, you have to keep in mind what is auxiliary space and what is input size, like we will discuss as for the example. But before that, you should keep in mind input space is like the size of the variables or variable used, okay, plus auxiliary space is extra space. Extra space, basically some extra space are needed. Like if I'll provide you a small example, uh, like if you need to edit a video, for that video editor is taking much space. Why? Because the video editor software is small, not an issue. This is your input size whenever you are downloading it. When you're installing in the background, it needs all the spaces for giving the graphical support. Okay, for graphics it needs some extra space. That auxiliary space is always being needed whenever we are purchasing a mobile phone or anything. If we are purchasing that time, what exactly we are focusing, we know 1 GB or 2 GB of space is enough for us, because we are actually for purchasing a mobile phone, because to connect with the nearer and dearer ones. In that case, what exactly will happen, do you know? Like we need extra, that sometimes we are giving photos, sometimes we are recording videos, sometimes we are editing videos, like to actually store the informations in future. Also we are using other applications too. In that application, whenever you are using, that is needed, the extra space is needed. Okay, so extra space plus the size of the variables which have been used is called as the space complexity. If you add both the thing, then it will give you the idea about the space complexity. Okay, because these are the space needed to complete a task. Suppose you are finding, like as per this example one, this is your example one. If sum of two numbers means two different variables you are taking, through which you are actually adding these two variables, and another variable you are using, which is sum here. So integer type, all are integer type, like integer a, b, and integer which is sum, a variable that we have created. There are three variables. Then sum is keeping all the data related to the addition. Next it will be printing this sum. Okay, so as per the space complexity which we read now, we have to divide, like the variable size which is input size, I am writing is as the input size. Okay, this is our input size. The input size are the number of variables that we are using, the size of the variables. As for the size of the variable, if the size of the variable integer, we are saying it is 4 bytes, that we have already read. And for float, it is also 4 bytes. But integer is not always 4 bytes, it is 2 or 4 bytes, but it depends on the compiler. Okay, now if your variable is double, then for double it is 8 bytes. Like there are other variables are also being present with the predefined data type. It's about the size of the data type we are using. Okay, the size of the variable means the size of the data type. In other words, I am saying it's the size of the data type. Okay, the data type size is also a part of the input size. Okay, from there we can calculate the uh, input size. Okay, I'm just writing the variables we are using. The variables are a, variable is b, and variable is sum. There are three variables, simply write it. And what type of variables are there? It's in int size. So in int, either 2 bytes you can write or 4 bytes. Better 4 bytes you can write, not an issue. Now I'm writing 4 bytes, 4 bytes, then 4 bytes. The next is auxiliary space. I'm writing AS is auxiliary space. This auxiliary space, how do we define? The auxiliary space will be defined as an extra space. Why we need, suppose to keep this one, to keep this, to store this one, and to store integer, to store commas, we are using the auxiliary space. Okay, and also here this bracket also we are storing somehow, because without storing it we cannot find it way. So auxiliary space, can it be a constant, because the 4 to anything we are writing here are part of constant. Okay, so whether we will consider this as constant or not, always remember auxiliary space will be n or anything if we are using any data structure. Here no data structure are getting used. Normally through the additions, you can say in background might be array could be used, but auxiliary spaces will be used if data structure is playing a vital role to operate, to give you the option, like to give you the result. Like in a recursion we are using stack. Okay, the stack is in the background. Without helping a stack, the recursion could not be run. The recursion will run and give you the proper idea. Then only the auxiliary space, you can say, it is depending on the size of the data structure which you have taken, like the stack. Okay, here no stack is used or no data structure is used. In simple, there is no use of recursive function or recursion. That's why the auxiliary space could be anything. Like, you can take auxiliary space as 4 bytes. Okay, or anything. Auxiliary space, you can say, instead of auxiliary space I'm writing as I'm just taking 1 byte, also I can take 2 bytes, also I can take anything, because it's not decidable by you. So our target is to finding space complexity. To find space complexity, I'm just writing it. To finding space complexity, it is adding of uh, input space and auxiliary space, which is uh, 12 bytes plus 2 bytes. So in total, the total complexity will be 14 bytes. 14 bytes means it's a constant. So better you should write big of 1. This big of 1 will be the correct answer for it. You can take, suppose instead of 2 bytes, you can take 8 bytes, not an issue. But 8 bytes means you are indirectly saying this is a constant. This is not a variable. Though it is not a constant, you are just writing it's big of 1. If you want to write big of C also, it is correct. Big of K is also correct, because you have to write it. The C and K are the constant here. Otherwise, it's simple. You will write big of 1. This is the correct answer. Next example. Here is example 2, where it is saying the array elements. Okay, as for this, we read the input size. First we have to write input size. Input size is the number of variables we are using is I. Okay, next we are using is n. Next we are using is sum. Fourth one we are using is array. Okay, array variable, you can say array in bracket or I, you can write. Okay, so we are using this array. Next, keep auxiliary space also. I told you the auxiliary space will be used if a data structure exactly helping you to run this. Here array data structure using not an issue, but the main reason is we should be thinking uh, this is there is no use of recursion. If there is no use of recursion, the auxiliary is always constant. Constant means you can say anything. I can write 4 bytes, and I can write 2 bytes also, anything I can write. Okay, previously I was taking 2 bytes, so I'm taking it 2 bytes now. Okay, so I these are integer type, so write 4 bytes, 4 bytes, n is 4 bytes. Here this sum is also 4 bytes, but here in array the number of, you can say, array will be like this. Okay, in array what you have to do, so if there are n number of, suppose think there is an array of 2 index, suppose there are index 1 and index 2, so each index is 4 bytes. each index 4 bytes, so 2 index also 4 into second index also take 4 bytes because this is integer type. Okay, for integer each index will be 4 bytes. There are two index, so two index means index number of index. If anyone is asking question what is the array size, then so the size of array number of index into uh, size of size of or you can say the data type, the size of the data type. Okay, size of the data type. So here as per this size of number of index is 2 and size of the data type is 4 bytes. Okay, so here in total it is 8 bytes as per our example. If the index are n, if index is n, let us think indexes are 1 2 dot dot up to n. There are 0 to n indices, suppose. Okay, instead of that I'm just writing 0 and here 1, here also a 0 and 1. These are indices. Indices should be written outside of it. 0 and 1 instead of any value could be written. Better we can write outside of it 0 1 dot dot up to n. Okay, if n number of indices will be there, so n into 4 bytes, simple you have to write it. Now space complexity will be complexity will be your is plus as, is plus as. Is is 444 which is 12 plus 4n plus 2 bytes. Okay, so in general it is 4n plus 14 bytes. Okay, so 4n and 14, 14 is constant, 4n is n is getting there at there, so total space complexity is big of n. You can write it is a correct answer. If someone is saying sir can I write big of c into n, yes, also write, where c is a constant. Okay, so here the maximum is 4n, then only we can say. If you can say sir why 4n we are taking, why not we are taking some 14, because here if n is 1 then we can say it is 4n, which is 4 into 1, 4 is less than 14. Yes, I understand, but up to which that we studied, that this diagram which is like f of n will be greater, here f of n and here c into g of n. One time what you'll say, so sometime it will be depending on the g of n, or sometimes it is less, sometimes it is greater, but one time will come where f of n will be lower if I consider the value of the n. If n is incremented in the previous video, you please check that one, there you will find up to certain range we might have some hurdles. After that there will not be any problem. So that is why you can say for n equal to 1 you can get the same thing, n equal to 2 you can get 8, 8 is also less than 14, but sometimes here with 3, 3 which is 12, 12 also less than 14. But when you are adding 4, from 4 onwards to infinity, it is not less than the 14. Okay, so that is why the 4n is the greater value that we are having. Understood? That is why we are saying it is our uh, the maximum time complexity, or sorry, maximum space complexity now is big of n because of the array size. Array could be, if n number of indices are there, we can say simply it is n into 4 bytes, which is n big of n, which is linear time space complexity we are having. Next, factorial of a number. We are finding there are two ways to give a solution. One is using iteration, another is using a recursion. This is your iteration one, like we are taking integer n, then we are taking this I value will be incremented, it will be having some certain condition, Based on the condition, it will be running. The factorial will be multiplied with the I value which is getting increased, then factorial will be we get the answer. Like for this, you write simply input size, which are the variable we are actually using is n. Now I will be the second variable, you can say, and factorial also will be the third variable we are using, and no other variables we are using till that. And auxiliary space that simply, though I told you there is no such recursive function is there, so you can take any number, any 2 bytes, 4 bytes, 8 bytes, anything could be the correct result for it. Next, though it is integer type, so you simply write 4 bytes. Okay, next 4 bytes, next 4 bytes. So here for this iteration one, the total space complexity will be, is plus as, which is 12 bytes plus 2 bytes, which is 14 bytes, and that 14 bytes indirectly tells you the space complexity will be big of 1 or big of c, where c is constant. You have to write it. If you are representing, instead of 1 you are representing big of c, there you have to write where c is constant, or if you are writing where big of k, where k is constant. Okay, next. So here factorial we are using, but here we are calling through a function call. Okay, but here we cannot using any iteration method. Previously we have used it. Now we have to segregate it. Input size means the variable we are using. N we have used till it, no other variables we are using now. But for auxiliary space, what we are going to use, the main reason is, though I told you that there should be, you can use the stack while using this recursive function. So here we will get to know how we will decide the auxiliary space. Okay, how we will decide the auxiliary space. Now you look at this. suppose factorial suppose factorial 3 we want to find, or you can say suppose factorial 4. What is the value of factorial 4, that how the stack will run. Okay, suppose we are trying to find. You can check for this. For factorial I'm just writing it f of 4. Okay, just for factorial I'm writing f of 4. Here the position of f of 4 I'm writing f of 4. F of 4 will be n into factorial of f of minus 1. Like you can check again, I'm just creating it in such a way that you'll understand it better. For factorial 4, I'm just representing it f of 4. You have to write n, which is 4, into f of n minus 1, which is 3. Okay, next one is f of 3. To find that, you have to multiply that 3 with f of 2. Now for 2, you have to write 2 into f of 1. Okay, but here once it is equal to 0, we are saying we should stop 1 into f of 0, and we know f of 0 is equal to 1 from this condition. If the value of n is 0, then the return will be 0, that we know. So we stop up to f of 1. Okay, to know f of 1, we need to multiply that 1 into 1, which is 1. This is the value that we got at the first level. Then what we have to do, we have to delete that one. Once we will delete, I'm just using another color. Once we will delete that, okay, suppose we want to delete, then only f of 1 value will be integrated, otherwise it will not be run. So now the 2 cross 1 will be written as 2 then. Okay, why 2 cross 2, 2 cross 1. Why? Because 2 is there already, f of 2, then f of 1, the value of f of 1 is 1. Now it is 2. Okay, now if you want to delete, then only it will like last in first out. That's why we are saying last in will be first out, then only we will get the result. Okay, so then the f of 2 value will be integrate, there will be input here, like here 3 into 2, which is 6. That we got the value of f of 3 is 6. Like we have to then delete or remove that index, then we will put the value here. Okay, next 4 cross 6 equal to 24, that we know the fourth factorial is 24. Okay, this is how it is running, like the number of index we are writing. So if you want to delete this one also, then you'll get the return value. Okay, then how it is running, the main factor, the main role we are actually have seen here is the number of indices for a factorial. Four index are needed or indices are needed. So like for f of n, how many indices then? N index, because here you can say 4 index. How? Here this is one index, first one, second one, then third one, then fourth one. First, second, third, fourth. 4 index for f of 4, n index for f of n then. Okay, each index will be, why we are saying it is in 4 bytes, because integer is getting multiplied. So here I am writing simply 4 bytes for n, and for auxiliary space I can simply write here auxiliary space, simply it is number of index into the size of index. Okay, so in total it will be space complexity is now addition of these two, which is, I'm just segregating this now. Okay, 4 plus 4n plus 4 bytes. So out of this 4n is greater, so better you will write the space complexity as this. Okay, or c into n also you can write. But remember one thing, you should be it should not be always focusing on the input size. Sometimes auxiliary space is also being helping you to find the space complexity. So remember, auxiliary space is also vital role if you are using the recursion or recursive functions inside your code. So I hope it is understood by you. Thank you for watching. Have a good day.